Here we have a projectile that's launched at 62.4. Here we have a projectile that's launched at 62.4 meters per second, 39 degrees above the horizontal, and the question is, what's the maximum elevation it reaches? Well, we're at, what's this angle? 39 degrees, right? And we're moving along at 62.4 meters per second when we launch. We've got to decompose this into, we've got our initial velocity. It's got an x component, right? 62.4 meters per second cosine of 39 degrees I hat. It's got a y component, 62.4 meters per second sine of 39 degrees j hat. Which one of these makes a difference in terms of the horizontal direction? Because we're asked for elevation, right? The only one that matters, the only piece that matters in terms of elevation is the y piece. So what is the maximum elevation during flight? Well, in y, we've got our velocity in y is minus gt plus v naught y. This, of course, is v naught y. What's Vy when it reaches its maximum elevation? Vy is 0 at that point because you come to a stop in the the y direction before you start heading back down. And so we're looking for the time given by V naught y over g. Okay, so now we know when it reaches its maximum elevation, and all we have to do is turn to the equation in y. Y is minus 1/2 gt squared plus v naught y t plus y naught. Y naught, of course, is 0 because we start off on the ground with this projectile. And so you're just going to plug in this time for time here, and that's going to give you when this hits its maximum elevation.